Leveraging GraphQL for flexible data retrieval, a star-based approach. In today's fast-paced digital landscape, offering users efficient, dynamic, and personalized experiences is a competitive advantage. I had the opportunity to lead a project where we used GraphQL to improve data retrieval flexibility for the mobile app's Travel Benefits API. This experience not only improved the app's performance, but also enhanced the user experience by providing faster, more relevant data. Below is a breakdown of how I leveraged GraphQL to drive this change, using the STAR framework: situation, task, action, and result. Situation: transition from REST to GraphQL. The mobile app had long been using a traditional RESTful API to manage travel benefits data, such as rewards, trip insurance, and lounge access for credit card holders. However, the app faced several challenges. Data overfetching. The REST API returned all available data for a particular endpoint, even if the mobile app only needed a fraction of it. This led to increased payload sizes and longer load times. Limited flexibility. REST endpoints returned a fixed set of data, which meant that every update to the data structure required a new version of the API. Performance issues. The API had become sluggish with increasing traffic, and it was difficult to provide a scalable solution to meet users' dynamic needs. The task at hand was clear: transition from the rigid REST API to a more flexible, scalable solution that could improve data retrieval efficiency, reduce load times, and provide a better user experience. Task: migrate to GraphQL and improve data retrieval. The goal was to implement GraphQL in the mobile app's Travel Benefits API to provide more flexible and efficient data retrieval. This involved several key objectives. Shift from REST to GraphQL. Allow mobile apps to request only the data they need, thus improving both network efficiency and app performance. Optimize data queries. Ensure that the API could handle dynamic queries and return only relevant data, reducing payload size. Seamless user experience. Maintain compatibility with existing app features, and minimize downtime during the transition. The task involved collaborating with multiple teams, ensuring backward compatibility with existing systems, and addressing the complexities of implementing rate limiting and OAuth 2.0 authentication for secure API access. Action: implementing GraphQL and enhancements. To ensure the success of this project, we followed a detailed implementation plan. API architecture design and integration. I spearheaded the design of a scalable API using Java Spring Boot, which was already the framework for our backend services. The core of the migration involved the following: GraphQL schema. Definition: I defined a GraphQL schema to allow clients to request only the data they needed. This schema mapped the existing travel benefits data to flexible query structures, reducing overfetching and improving app performance. Rate limiting. I implemented rate limiting to ensure that users couldn't overwhelm the system with excessive requests, especially during peak usage. This was critical to maintaining system stability. OAuth 2.0 authentication. I added OAuth 2.0 authentication to ensure secure access to the API, ensuring that only authorized users could query sensitive data. Cross-functional collaboration. The migration required close collaboration with 5 different teams: backend, front-end, security, product, and DevOps. Backend. The backend team worked on implementing the GraphQL resolvers and integrating them with our existing data sources. Front-end. The front-end team had to modify the mobile app to handle GraphQL queries and ensure data was displayed according to the new flexible structure. This involved significant changes in the app's data flow as it shifted from REST endpoints to dynamic GraphQL queries. Security and DevOps ensured the security of the API through OAuth 2.0 authentication and implemented rate limiting to protect against abuse. Communication and user education. One of the most challenging parts of the project was ensuring that both internal teams and end users understood the transition. Internal communication. I facilitated workshops and training sessions for all stakeholders to ensure alignment. Detailed documentation was provided for developers to understand how GraphQL queries would work. User communication. Externally, we communicated the change through in-app notifications and release notes, explaining how the new system would improve performance and what changes users might notice. We also reassured users about the migration timeline and how their experience wouldn't be disrupted. Testing and rollout. We performed extensive testing during the transition, running A/B tests to compare the performance of the old REST API with the new GraphQL implementation. The testing phase involved simulating real-world usage, testing how the new system performed under high traffic and various user conditions. Beta rollout. We rolled out the new system to a subset of users to ensure it was working as expected before going fully live. Result: improved performance and user experience. The results of the project were highly positive and aligned with the original goals. 50% reduction in API response time. The shift to GraphQL resulted in a significant reduction in API response times. Since the app only requested the data it needed, we saw an average reduction of 50% in load times for travel benefits data, improving the app's performance. 35% reduction in network payload. With GraphQL, the amount of data transmitted over the network was reduced by 35% on average. This not only sped up the app, but also lowered data consumption, which was especially beneficial for users with limited data plans. Enhanced user experience. Users experienced a much faster, smoother app experience as the app became more responsive. The dynamic data retrieval approach also allowed users to receive the most relevant information, improving their interaction with the mobile app. Successful migration with minimal downtime. The migration was completed with minimal disruption to the user experience. Thanks to careful planning and backward compatibility with the REST API, the transition went smoothly. Lessons learned. This experience taught me several key lessons. Cross-team collaboration is vital. Effective communication and regular sync meetings are essential to ensure that all teams are aligned and that dependencies are managed effectively. Testing is crucial. A gradual and well-planned rollout with thorough testing ensures that issues can be identified and addressed before they affect users at scale. User education matters. Communicating the benefits and changes to users can help smooth over the transition and ensure they understand how to make the most of the new features. Conclusion. Leveraging GraphQL for flexible data retrieval was a transformative experience that helped improve both the performance and user experience of the mobile app. By following a structured approach, focusing on cross-functional collaboration, and carefully managing the migration process, we were able to deliver a more scalable, efficient, and user-friendly solution. This project not only improved the mobile app's technical capabilities, but also deepened my understanding of how to manage complex transitions in a large-scale environment.